Oh, wow. Okay. Right. Good escalate. Yeah. Yeah, I see. All right. Okay.
And it was very cool
Um,
this morning also. So my nose got dried up and then the dust went in, I guess. And yeah.
right.
The heavy rain.
Um, it was a heavy rain, right? So tell me if you're not feeling very well today, yeah?
Okay.
What should we do today?
I actually didn't struggle that much with the normal distribution. Actually, I don't have any questions from that tutorial. So I think either we can try attempting the sampling and estimation theory questions, or we can go through hypothesis testing. Because there's a lot of things that I don't understand from hypothesis testing.
Yep. If you have gone through, let me help you clarify things up.
Okay.
Please do. So I'm in the 16 April, page 4.
Okay, sorry?
I'm in the 16 April Jamboard, page 4.
Oh, okay. I think it would be better to go through hypothesis testing. The working looks very standardized, but I don't really understand like what's going on.
That is the issue. Same thing with normal. Once you understand, so we take time, we go slow. Once you understand, like 90% of the question makes sense, and the solution is never that complicated. So our task, like normal, is to understand what's going on.
Okay.
With that in mind, if you want to ask lecture notes, now is a very good time.
I think it's more of just in general, like I don't really know what critical region is. All the terminology, I'm not very sure.
Right.
And like how they can derive a conclusion from the calculations and all that. Yeah.
I'll talk about a few basic stuff, see whether it makes sense.
Oh yeah. For context, this kind of appeared in H2 bio also. We have this thing called the chi-squared test, and they mention like level of significance, critical value. Yeah.
I know those are formalities, but let me tell you the story, right? So we do not want to survey everybody. That is always the point. The question will tell you that most of the time, the question will tell you that the mean of population is this, and the deviation of the population is that. And he will probably not ask you to find it. He will probably provide that mean and deviation of the population, plus the assumption that the population is normal. That is almost always the case in hypothesis testing. They can deviate from that, but it's very rare. So there are three things. The fact that the population is normal or assumed to be normal, the fact that they tell you the mean and the deviation of population without asking you to find it and without explaining where it is from. It is there, meaning to say that was past data. Somebody tried to measure that in the past. Is it really measuring everybody, or is it really sampling from the past? Don't know. We just take it as it is, right? That would be before any hypothesis testing is happening. So we know stuff the question will tell us. So far, so good?
Okay.
Now, if you know that the population is normal, that you know the mean and you know the deviation, then why bother sampling again? That should be the question, isn't it? Why bother? You already know everything. If you know that it is normal, distributed, and you know the mean and your deviation, is there anything else that we don't know? I mean, nothing much lah. We know already. Loh. Makes sense, right?
Okay, yes.
I mean, give it the vision that under normal tutorial, like they don't tell you everything. Usually, they ask you to find it based on something else, right? But in the hypothesis testing, hey, we know everything. So why is there a sampling, another round of sampling, which leads to the hypothesis being tested? So we know this. Then we still sample. Then from the sample, we have a mean, right? A sample of the mean, right? We have that, right? Which you already know, the sample of the mean of the sample is not the mean of the population one. It's not. Because a sample is just a small part of the population. So the mean will not be exactly the same, right? Everything still makes sense, right?
Okay.
Right. So the difference in the sample mean and the supposed population mean is not the only reason why we suddenly have this hypothesis testing, because they are supposed to be different. They are not supposed to be the same. It doesn't follow that they are the same, right? It doesn't follow. So why is there a hypothesis testing? Because the guy doing the sampling has a certain claim that things has changed, probably. That means the population undergo a certain change, such that maybe their mean is no longer reliable, so it's no longer that mean. Maybe the deviation change, that's very rare. That's very rare. In your syllabus, we only usually talk about, hey, the claim is that the mean of the population changed for a certain reason. So they do give you a qualitative reason, and then they claim that the mean changes. And the claim must be, so to speak, tested law. So the claim is the hypothesis. The hypothesis is the claim. There is a claim that things have changed. I am going to do another round of sampling in order to check that claim. That's the hypothesis testing. Then based on whatever procedure, which is very standardized, I will say that is the claim okay, or is the claim not okay? Again, the claim is usually that certain things change, the mean usually. So has the mean changed or has the mean not changed? That is the result of the testing. That's just what happened in the hypothesis testing. Now, am I making any sense?
Yes.
Right. So that's it. Now, at that point, do you understand what I've just said? As in, you already understood it before I said it, or?
I mean, I understood a bit more, but yeah.
So roughly you understand that, right? Roughly you understand that, right? So therefore, the situation is very simple. The situation is extremely simple. In page 4, I will draw something. Now, usually until normal, we draw the population graph. You know, I ask you to draw this, they ask you to draw the standard. That's the population graph. That represents the real thing, right? In hypothesis testing, we are not doing that. We draw a graph, which is a normal graph, yes, which has a mean, but this mean is the sample mean. It's a sample mean. And why is there a standard deviation? Because the samples collected, at least 30 or more, right? 30 or more, we'll have a deviation. So we'll have our sample deviation, right? Sample deviation. Okay.
Okay.
So this graph is not the real thing. This is just from the sample we collect, right? And then here comes the original supposed mu of the population, which they usually tell. So let's say for some reason, the mu of the sample that we measure is, let's say, equals to, I don't know, 67. Don't know what that is, 67 grams. Then the original supposed mu of the population, give me a random number somewhere close.
Original, 35.
35 is very far from 67. That's unlikely to be right.
Oh, no, sorry, I was looking at the wrong number. 60 lah.
Okay, 60. Whether 60 is far or not, we'll find out soon enough. But 60 is here, no? Right, so we just put it here. And then maybe somewhere there, right? 60 there. 60. So again, obviously 60 is not 67. But even if the mu is 60.5, let's say, of the sample, and the original mu population is 60, that might look close to us subjectively. What is half? What is half? Well, it depends on the deviation. So the graph might actually look like this. Here's your 60, the supposed original. Here's your 60.5, your sample. And then the graph deviation is such that the graph deviation is so small. That means the standard deviation is only 0.1. Okay. So look at this graph for a while. Look at this graph. I purposely make it very visually, visually obvious, right? The guy claims that the mu of the population has changed. It is no longer 60. That's the claim. And then he measured the sample, and the sample give him 60.5. He doesn't know what the sample give him. He just claimed that there's a change. The sample mu is 60.5, and the standard deviation of sample is 0.1. You just look at this. Do you think that the claim that, the mean has changed is, reasonable or not?
Yes.
Yes, because the standard deviation is so small. It's not just about this direction. It's about the standard deviation of the sample.
Okay.
Right. I think it is very unlikely that the sample didn't change. It's very unlikely. What do you think? That makes sense, right? Very unlikely.
The sample.
Unlikely. Because the sample is 60.5 and the deviation of the sample is 0.1. It's very unlikely that the mu of the population is 60. This is already very suspicious. It's based on the graph, it's very far from 60.5. 60 is very far from 60.5.
Okay, I get what you mean. Yes.
Right. So the sample kind of like because again, sampling, if the sample is well done, it's not biased. The sample is well done, and which is always the case. It's very rare that in our question, the sample is not well done. That's I guess a university topic. The sample is not well done. We don't talk about it here. We just take it that the sampling is well done, unbiased, right? Then the conclusion should be that the thing has changed, and all the critical value, blah 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 blah, is just to verify that. It's just to quantify that.
Critical value.
Very simple one. Very simple.
Okay.
Again, notice that I am not drawing the population graph. Notice that, right? I'm drawing the sample graph, and then the population, I just extract the mean. I'm not even concerned with the population standard deviation, right? That's a quirk of the syllabus. We don't care at the hypothesis testing. We don't care. We care at the more pure normal one. Okay, so only here. Okay, only here I don't care.
The standard deviation that's given in the question is always for the.
It's usually the population. They usually give the population one. They usually do give the population, which kind of tells you that why, right? Because you can use it for the sample. You'll see later. I'll just go through with it. Okay, I'll just go through with you later. Right. Okay. So now, the 60 is my only. I only take that from the real population, right? 60.5, and the critical region is represented like this. The critical region talks about, again, the sample graph, right? So he talks about frequently 5%. Okay, please notice that 5% is not exactly first 1 or 2 or 3 standard deviation. Just saying, right? It's not exactly that, right? Because remember, standard deviation, first one, this is 34%, correct?
Yes.
And then the second one, this is -1, and then -2. Then this is 2.5% over here, right? Whatever this is, 5%, what he mean by 5% is usually something like this, right here. So slightly here, and this will be your 5%. So it's slightly between the first and the second standard deviation. If this is one tail, right? Okay, so far so good. Right.
Yes.
But 5% is a kind of, I should say, this is a random number that they choose. You would notice that most questions will give you one. Okay, give me the confidence value. Okay, I'll give you the confidence value. You just use that.
Wait, this is
The confidence values, the
level of significance, is it?
level of significance, confidence value, critical region, they are all talking about the same thing one.
Okay.
So 5% or 1% or 10% or 0.1%, 90% of the time, it's up to the question. It's up to the question one. Now, obviously, the smaller, the better, or the bigger, the better, you'll see later. That's part of your understanding, right? But my point is right now, this question is just randomly set by the value is randomly set by the question. Yeah. Okay. Right now.
Okay, so level of significance is literally like how confident they are in like
in the conclusion, no? In the conclusion.
Oh, okay.
Yeah. Okay. So I mean, which one's better, big or small? That's for our understanding to grapple. But the question don't care what. The question, if the question said 5%, then just tell me whether the hypothesis will be correct or not accepted. Just tell me. The question will just say that. I'll just set it for you. Very rarely, the question reverse. So the question will say something else. If I want the hypothesis to be accepted, what kind of confidence interval? He's reversing the situation. Very rarely one.
Okay.
Yeah. Now I'll put the confidence interval 5% left tail. Okay, here. Okay, left tail. So here lah. So roughly, I'm going to draw here. Okay, that's my 5%, and this value is probably around, because it's close to the second standard deviation, right? So maybe that is around 60.33, maybe something. Okay, there. Okay, so far so good. So far can follow, yeah.
Wait, where did the 60? Oh yeah, okay, never mind.
Okay, just okay. So keeping it very simple, this is your logic playing first. If the original mu is not on the red zone, so for example, I'll give you an example. So for example, it is here. That's the original mu. The original mu is 60.4, right? For example, let's pretend that there is no 60 right now, right? Okay, can? So far so good?
Yes.
Right. So according to you, should you conclude that the mu of the population has changed?
No.
No, because qualitatively speaking, they are too close. They're too close. But what is close or not close? It is defined by the 5%. So let's say the original mu is not 60.4, but 60.3. You know, just nice over the red zone, right? Just nice. It's very slightly in the red zone. But there you go, look. There you go. So should we conclude that the mu has changed?
Yes.
Yes. That's it, look. The number 60 is no fun, because if the number is 60, it's so easy to conclude visually. Yeah, it's so far. I don't need the critical zone. Why bother with the critical zone? Obviously, the question will give you, numbers that are rather close, in or out of the critical zone. So it might mess you up. It might mess you up.
Wait, why is it like rejected if it's not in the critical zone? And why is it accepted if it's in the critical zone?
This accept or reject, I will put aside first. I will just say the word change or not. That's slightly better.
Okay.
So 60.4, we think it changes, right?
Yeah.
If the original music, but if it is originally 60.3, looking at our sample graph, I'm sorry, 60.4, we think it doesn't change. Sorry, I'm going to talk about, right? 60.4, we think it doesn't change. Because 60.4 is rather close to 60.5, right?
Yes.
Original, again, original sample, right? But if the original is 60.3, then we say that's far enough from the sample mean. Okay, we think it changes.
Okay.
Something like that.
But why though?
Because the question set is the question that says 60.33, the 5%, right? The 5%, thing. 60.33 is the limit where you say change or don't change. That's the limit. Do you cross the limit or not? That's all.
Then what if they change like the 5%?
The limit. Yeah. They can. So the question will say 5%, confidence. Then 1%. Will your conclusion change or not? Yeah lah. It might change, obviously. Because the 5% is not about the area. It's not. It's about the 60.33. The 60.33 is your limit. Changing the percent changes your limit. You may achieve a different conclusion. Obviously, what? But it's just like that one.
Okay, maybe the one that I'm actually confused about is what does this actually mean? Like the 5%, the 60.33.
Right. Again, the sample graph, right? So the sample graph has its own mean, 60.5, standard deviation, 0.1, and then the confidence level, blah, blah, whatever, 5%. Using your standard normal knowledge, you will get the 60.33 value, don't you think? That's just inverse normal, correct? You're just inversing normal in the sample region. Then I have a limit called 60.33. If I go to the left of 60.33, I am too far from the sample mean. Therefore, the distance is big. If I'm at the right of the limit, we say, the distance is small. I don't think it changes. That's it. How far or how close? Defined by that limit. If you're half okay, half not, good enough, let's just do a question, shall we?
Okay.
Put a question, please. Whichever question you want from the lecture note, from the tutorial, whatever.
Okay, maybe I go on the next page.
Sure. That's FYI, Elliot will be in at 8.
Okay, sorry.
This is Elliot will be in at 8. Just FYI. Yeah. So 3% lah. So why 3% are the question sets, right? The question set, simple, right? Now, look at how the question is structured. Never mind the one-tailed test. Never mind that, okay? Never mind that. Understand the situation. That's more important. Yeah? Look at the situation. As I told you before, there are past data. Here's the past data. Correct on past data. This past data is the supposed population, which CC data is normal. So see, we know everything about the population already. Correct?
Yes.
But there is always new data. There's always, a future data and a math test, a new math test. This is experience has shown. He's basically saying, from 2000 until 2022 lah, basically something like that lah. Let's just say that. Let's pretend that that's experience lah. So from the past 22 years, 23 years somewhere, this is the mean and this is the variance. That's a lot of data, correct? That's a lot of data. Then the math test at 2023 lah, right? New data loh. Okay. New data. So new data, the sample is only 49 students. Sorry. So, no. It's not even just it's not 49. This must be a test. I mean, he can do a test for 1,000 and take 49, or he can just do 49. That's up to them, right? So random sample of 49. The mean is 68.5, which again, we don't expect it to be 70 anyway. So it is fair to ask the question, hey, this is 68.5. This is below 70. Are we in some kind of trouble here? Maybe, maybe we didn't teach very well today. Maybe the COVID is still doing this, doing that. Maybe.
Okay.
The reverse is true, Let's say the 49 student gets 72, and the question can just change like that one. 72, which is not 70, right? 72 is not. Then should we suddenly, have a party because the student is doing better than expected? Should we or should we not? I think this is a very, how do I say? It's a very practical question. I feel this is not something that you create out of, it's not an abstract random thing. You do want to know. However, if the sample of 49 students is 76, I think there are only two possibilities. Either the sample is very biased, you just take, you just happen to take the better performing student, right? That's one way to bias the sample, right? Or the student really, really did better. Or more likely the question is too easy. Or more likely, right? More likely. So the student is performing better. Why? The question too easy. Oops. Right. But when in a borderline cases like 68.5, we do hypothesis testing. Again, that's where the questions will be at borderline stuff, not at obvious stuff. Not definitely.
Okay.
So let's see how they do it. Okay, let's go through the formalities. Just show the formalities properly, and I'll show you what it means.
Okay, so what do I have to do?
The solution. You copy the solution fully, unless this is full already.
Okay.
Okay. Yeah, he didn't draw. I mean, why would he? I'll follow his method. Okay. So I'm drawing a graph. Drawing a graph. Yeah. So look at this thing for a while. I think the notes will present this as as a formula, just using something like that. So like the variance of the sample, the unbiased, the unbiased estimate. Never mind. This 36 over n, the variance over n, is what they tell you to use, like something like that, right?
Yeah.
What they tell you to use, right? Okay. So notice that the bigger the n, just notice this for a while. The deviation of this is the sample, by the way, this is a sample. The deviation of the sample reduces.
Yes.
Reduces. So it's a very simple thing to understand. So again, the sample, here's a sample. If I only take 10 sample, my deviation my deviation rightly is larger, n equals to 10, then when my sample is, let's say, 100. When my sample is 100, my graph will look like this. The mean is n is 100. So this is when sample is 100 and when sample is 10. This makes a lot of sense. Why? Because remember, the sample is just a representation of the real thing. If your sample is very big, your certainty should be higher, and the certainty being higher is represented by a narrower graph of the sample.
That makes sense.
I hope this is logical. So I'm trying to explain why the formula works then. So because if the sample is too little, too few, Elliot, I can see here. If too few, then obviously you will have a harder time concluding. Here's your 70 and here's your 68.5, right? But if the sample is already strong, that means very narrow, then you will have an easier time concluding whether yes or no. Whereas look at the bigger graph. I mean, you want to say yes or no, also, it can go here, it can go there, right? The logical solution is to sample more, right? Go and sample more. Something like some question will tell you the result. So what kind of sample size should I get so that I can, confidently reject this at certain percentage? That makes a lot of sense.
Okay.
Right. So then the rest is the formula. So if you already understand where the z value comes from and everything, then
actually not really.
Right. So this is 3%. Okay. This is your inverse. This is your inverse normal 3%. Left tail, I think 3% left tail. Just try. Let's try this. So Elliot, my intention today is to go through the INDIS foundation. I mean, for the purpose of exam, but also for the purpose of just strengthening you, right? Because it seems that one a bit wonky, right? But if you have some better idea about what we should do, you please tell me. So what do you think, Elliot?
I think we do the indices.
Right, but we go from foundation. I'm trying to build the foundation, the feeling and the logic better. Then we go to the question. Would that be okay? Right. So we do have today, right, 1.5 hours, and then next week, no. I'm gonna ask you what should we do next week later, right? Okay, because next week I'm not in Singapore, but we probably can do something. So shall we use the previous Jamboard just to save time?
Yeah.
Earlier that Wednesday, so it's yesterday. Okay. So I will trust that you and Kakak Brian has discussed enough of the polynomials, long division, everything, factor
yes.
And if it is not enough, you practice yourself first, right? Okay. So we're just going for INDIS today, right? We are also going to ignore log for a while, right? So I believe page 12. Oh, is it Keiko? Is that your inverse normal 3% left? Blah, blah, blah.
So area I key in 0.03, right? Then the mean, do I use the sample mean or the population?
No, this is Z, ma. This is the Z value, ma. at the
this
z
is the
value.
actual z value. Oh,
Z ma,
okay.
Z ma. So keep it easy
Okay,
first, like
okay.
at Z first, right? So you just go 0, 1, right?
Yeah, then it's correct. It's the inverse.
Yeah, so that's where it gets from, right? So the 3% determines the limit. This is the limit in the Z value, right? This is the limit in the Z value. So notice that he converts the, he converts the 68.5 into Z value also. Correct? Correct.
So that
So
this thing is just the substitution.
It's just two graph up and down again. Same thing, right? The Z graph and the, right. In this case, the real is a sample, right? This is a sample. Okay, so Elliot, I can see your video. Yeah, on your video, first you'll be needing your paper, right? So basically, he converts 60.85 as minus 1.75, and then the limit brought by the question is minus 1.88. Whatever the hypothesis is, just put it this way. Minus 1.75 is rather close to 70. Keeping it that way, correct? Because the limit is here, ma. Correct or not? The limit is here, ma. So 68.5 is rather close to 70, not far. That's our first conclusion first. Does that make sense?
Okay. Yes.
So we cannot say that 68.5 is actually different from 70 because it's rather close. That's what we're trying to say. Since 68.5 is still close enough to 70, we shouldn't conclude that there's a lowering of mean. Therefore, the conclusion, I word it in a totally different way for you to understand.
Yeah.
You understand me? It's close enough, so don't conclude that it's far. If you conclude that it is far, that means there is a lowering. That's it.
I think I understand that part, yes.
Mm-hmm. Never mind the sentence. The sentence, you will just repeat yourself until you bubble from your mouth. Understand it. And look at the question every time. It's going to be like this.
Okay.
Never mind the formalities, but understand why the conclusion is like that. As I have promised you, it's just about near or far. So please try another question while I'll help Elliot, okay? Okay. Elliot goes like this. Page 12, you see me? Positive 12 and right. So give you an example. 2, 3. Okay, so at page 12, Elliot, I just wrote an index. Right now, you are at least comfortable with this. If you're not comfortable, tell me that you're not comfortable.
Okay.
Yeah, so comfortable. So I'm going to summarize what is going on. I'm going to summarize the almost all the in this law in a way that is hopefully easier to apply, right? Okay. Now the 8 comes from 3 plus 5. If you know why, even better lah. If you don't know why, you must be memorizing them. Let's say that that's okay for now, right? If this is division, this will be negative, right? So far, so good, right? Same thing, like that's what we memorize. This is the easiest one to memorize. Now I'm gonna summarize things, right? So positive times, right? And then here you have power, right? You have power, and then you also have root, right? So the first tier we learn in, before we learn from, I guess we learned this from nursery to P1, and then suddenly at P2 until P6, we're basically using this one. And then this starts from secondary 1 and so on and so on, right? Until now it's in this. Okay, Keiko, I see your question, so try to understand it, right? Try to understand. Now, this is my summary, Elliot. So you have this thing, you have this thing on the bottom, right? Let's call this the bottom level, right? Affecting the guy on the top level, correct? Bottom level affecting the top level. Okay. If this is time, Then for some reason, whether you know or not the reason, it changes into a plus. If this is division, it is a negative. So I'll call it this way. If I want to kind of, simplify the matter, that means I have to go from bottom level to top level, because, this does look simpler than this one. If you can do it, that's fine. If I want to go from bottom level to top level, my level here must drop. Very simple. So if my bottom level is times and divide, which is here, correct? And I want to go up to the top level, I must downgrade them. I must downgrade times to plus. I must downgrade the negative division to negative. It's as simple as that. You understand what I'm saying? Because I want to go up a level, the sign must downgrade.
Okay.
Right. Now, this has some implication, right? So if my top level, if my bottom level is now something like this, 2, 3 to the power of 5, right? Now, this is not considered the top level yet, right? Because this has not entered here, right? This is still considered the bottom level. Does that make sense? This 5 is still dealing with 2 power 3, so it's a bottom level. Hey, I want to simplify it. So remember, if my top level is here, right? My top level is here. If I want to simplify, then I have to downgrade to times 3 times 5. Don't know why that's correct, but that will be correct.
Okay.
You see the downgrade? If I want to go from bottom level to top level, I have to downgrade my sign. Okay.
Yeah.
Same thing here. 2, 3, root 5, right? So my bottom level is root. So if I want to simplify things, I will have to go to division. So 3 divided by 5. Correct? Okay. I just did a downgrade. This is what you have been learning. I'm just trying to summarize stuff. This is like very consistent. That's why I can summarize it. Now, what happens if the bottom level is plus? So 2, 3 plus 2, 5. Where are we at the bottom level? At the plus and minus level, correct or not?
Yeah.
At the plus and minus level. Hey, I want to simplify, Lei. I want to simplify. I'm dying to simplify this. Can I simplify? I really want to simplify this. I want to simplify this from 2 things to 1. I want to go from bottom level plus to top level something. Can I do that?
No.
I cannot. Correct. Because there is nowhere to downgrade. The short answer is wait, you cannot do this. Wait, just wait for a while. You can't do this. My point is what you cannot do is as important as what you can do. This is important. I'm not explaining why you cannot do it, but at least I'm making it, easy to remember. You cannot downgrade anymore, so you cannot do. That's what you should be thinking for now. Oh, I cannot do this. There must be another way to do it. Not this. Will this be okay so far?
Yeah.
Right. Now let me try to give you a lot of examples. Let's see whether you can handle it. But before that, one more thing, right? So I can always you do realize that I can go from simple to more complex. I can do that, I'm allowed to do that, and sometimes I have to do that. So for example, this is 2 to the power 8. I can see 8 as, 2 plus 6, correct? So therefore, if I want to complicate things, I can do like that. And sometimes I have to do this. This is not playing joke. I can do that. If my top level is plus and I want to go to bottom, then I upgrade my sign from plus to times, right? Same thing, just the reverse. Okay.
Okay.
If I see my 8 as 2 times 4, what can I do? What can I do? I can look at this as 2 to the power 4. Because remember, if I go to the bottom level, I have to upgrade my sign from times to power. Or 2 power 4. I also can do that. And this is also something that I have to do in questions. Does this make some sense?
Yes.
Right. Now, lastly, I can see 8 as 2 to the power 3. I can see that also. So this is currently 2 to the power of 2 to the power of 3. I mean, it looks so complicated, for goodness sake. It is complicated, right? My question is, can I want to go from top level to bottom level. Can I do that? Can I do something about it?
I think so.
No, cannot. No, cannot. Because there's nowhere to update. My top level is already a power. If I go to the bottom level, I have to upgrade, right? There is nowhere to upgrade. I cannot. I cannot do that.
Okay.
Do you understand?
Yeah.
One more time. If my top level is plus minus and I go to bottom level, it becomes time flow. I have to upgrade from top to bottom. Then I have to upgrade. If I see my top level as times, I want to go to the bottom level, I have to upgrade. I have to upgrade to, power, right? See, I upgrade. If my top level already power and I want to go to bottom level, I have nowhere to upgrade. I cannot. I cannot do that. That's the summary.
Okay.
I'm not saying that this is a good reason, but this is very consistent with what you're learning. So that's the summary. Okay?
Yeah.
Okay, yeah. Now, is there anything else regarding in this that is so basic that you want to clarify with me? It feels basic and you don't get it. Clarify with me before I start to try to confuse you.
What was counted as basic?
What I taught you was basic. Just now. What I summarized for you, that's basic. Because you need it every time. What basic means that you need it every time, no matter what question. That kind of understanding is what you need. That's basic. Basic doesn't mean easy. I don't think anything is easy in this lab. So, what you need every time. That's basic.
Okay.
You can take a look around if you have your notes, Keiko, are you okay so far?
I got confused by the phrasing of the question a bit just now, but I think managed
Right.
to
Is it
understand.
right tail or left tail, right? Maybe that's your confusion.
Yeah,
Maybe, right? It's 7%. Yeah, the 7% is not important. The value minus 1.4 is what's important. Correct or not? That limit is what is important. Yeah, it's not good. So that is what is important. The 7% itself, not so much.
Okay.
So you have your 2.5, and then there's a 2.6, right? 0.6, yeah, 0.6. So 2.6 is what kind of Z value? I guess you can call it that way. Elliot, anything that feel basic that you wanna clarify?
How about the same base and same power?
Okay, let me explain that. Still considered basic, and therefore something that you always want to think about. So what I mentioned just now is something you want to think about all the time. This same power, same base thingy is also something you want to think about. Now, I'm gonna write my summary first. Right, the summary kind of looks like this, right? Something like on page 13. Are you there?
Yeah.
Okay. So, I am talking about the bottom level only. My bottom level can be at times or divide. So, example, 2 to the power of 5 times 2 to the power of 7. See, my bottom level is times, correct?
Yeah.
Okay. My bottom level also plus minus. This is also what I'm addressing. So 2 to the power of 5 plus 2 to the power of 7. Right. Now, you might have noticed this from doing question. If the bottom level is times divide, that tends to be easier to manipulate. Like this is the sweet spot. This is the sweet spot of manipulation, right? So I summarize it this way. If you want to be able to simplify, you have to fulfill one criteria. Either the base is the same or the power is the same, right? So or 2 to the power 5 times 3 to the power 5. These two situations are base the same and or power the same. You can do something, and that something is usually simplifying, which is usually good. Let me make this very clear. If this is 2 to the power 5 times 3 to the power 6, can you do something about this?
No.
Cannot. Why? Because none of the base or power are the same. So you have to make them the same first before you can do anything. Again, usually simplifying.
Okay.
Right? This is something you want to think about every time. Really. Can I do something about this or cannot? Does it fulfill the criteria? The criteria is as simple as whether the power the same or the base the same. For times and divide bottom level. Okay?
Yeah.
Now, for the bottom level plus and minus, which is here, right? Which is there. Both the power and the base must be the same. It's both. It's a stricter requirement to be able to do something. Recall that just now when I summarize things, you should already conclude that there is nothing I can do. Because, because the bottom is plus, if I want to go to top, I have to downgrade. I cannot downgrade anyway. I cannot do anything with this by, right? That's the conclusion. Okay?
Yeah.
Right. So there is something to do. It's a very specific to do, and the requirement is that the base and the power must be the same. Right now, do notice that the base is the same and the power is not. Right. Do notice that. Right. So what do I do? Now, Keiko, I see that you are at the conclusion level. Are you happy with your understanding?
Yes, I just
Does it feel that, you're saying?
I still don't really know what significance level means, but besides that, I think I get it.
Correct. So never mind that first. Like seriously, never mind. You don't understand the phrase significant level, but you can do all this, all you understand.
Okay.
Of course, I'll try to explain it later, but I'm trying to focus on the bare minimum of understanding. The question feels like I can understand it. The way to do it feels that, I can do it because it makes sense. That's what I'm concentrating on. Okay. If you please try another example, because you will agree with me that the way to do this question is very similar to the previous one. Correct? Please try again. Please try something.
I mean, there's the two-tail one, right? That's right below this.
Yeah, can try. Left tail, right tail, two tail. I mean, is there a big difference? Let's see. So Elliot, what can we do in this weird situation where I told you already? What is the criteria if I want to be able to do something? Both the power and the base must be the same, right? That's the criteria. So I must change it to 25 plus 25 times 2. This is okay? I just split this. Would this be okay?
Yeah.
Right. Notice why I'm doing this. The base is the same and the power is the same. Correct?
Yes.
This is the very specific thing to do. Let this be y. Therefore, y plus y times 2 squared equals to, this will be equal to 4 plus 1 y equals to 5 y. Okay. That I can do that. I'm not sure whether this is helpful to the question or not, but at least I can do something. This is the criteria of whether I can do something or not. Do you understand what I just said?
Yeah, but why suddenly become 4 plus 1?
This is y. This is 4y. 5y. Simple algebra. Correct? Don't overthink it. This is 1y. This is 4y. Y plus 4y. 5.
Okay.
That logic you already understand. Use your logic. As in, don't think about it as a formula. Don't think about it as something that is mysterious or new. It is not. It is not.
Okay.
This takes care of 90% of indices. Everything in the indice question is settled by, can I upgrade or downgrade? And can I simplify or not simplify? Those are the two questions to ask every time. I guarantee you this. Okay? Again, I promise you, this settles most of your problem. Only the weirdest or the hardest requires something more. These two is enough. Now, put a question, and then let's do it together. Let's see whether my summary is actually that good or I'm just bluffing. Please.
Like a simple question or what?
Oh, that's up to you. But not a question that you have fully understood. No. No need that. No need that. You choose. Please don't put a question that you have fully understood. Which one do you want me to?
How about question 2D?
2D. I will do so. So we might be touching the third basic. Let's see. So in question in page 14. Yeah, okay. So I'm looking at this, I'm looking at that. The base is not the same and the power is not the same, correct or not?
Yeah.
To be fair, the relationship between the left-hand side and the right-hand side is not times divide, it's not plus minus, and it is not power and root, right? My first summary lah. Right?
Yeah.
But I don't care. There's a left-hand side and right-hand side. I'm going to use, the fact that, I remember somehow Kakak Philip or Kakak Brian or my teacher told me that at least the base must be the same or the power must be the same for me to even do anything. That's the second summary. Correct or not?
Yeah.
I don't think I am good enough to make both the base and the power the same. I don't think I can do that. But at least let me make either the base or the power to be the same. At least lah. Does that make some sense? At least lah.
Yeah.
And now, Elliot, you have a decision to make, lo. This is partly based on your experience. It's feeling lah. Do you want to make the base the same or the power the same in this situation? You gotta choose one. Try.
Make base.
Correct. Okay. Your decision, which is partly feeling, right? You must admit it's partly feeling one. So you don't really fully know why, but let's try. Okay, base the same. Then you must make the second decision. What should the base be? For example, should 3 become 1/9? Or should 1/9 become 3? Or should both change? Those are your three options. Does that make sense?
Yeah.
All right. So you have a decision to make, no? So what is your decision? Partly based on feeling also. Yeah, your total value looks good. Yeah. You're saying make
3 to 1/9.
Okay, I want to make 3 into 1/9 to the power of something, right? Correct? To the power of whatever lah. Okay, and you can do that. No problem. Now I will do this for you first, because this is the third summary. I haven't summarized how to do this, but let me do that to show you that it is effective. It is effective. So let me do that. 3 power 1 is equals to 1/3 to the power of -1. Would that be okay?
Okay.
Right? Equals to 1/9, man. So I must acknowledge that this is 9 like that, right? I must acknowledge first. Okay?
Yeah.
It's okay. Which is like that. Okay. I'm getting closer to my goal, right? Which is 1/9 now minus half lah. This is also basic. This is also basic. If you don't understand how to do this, we have to talk about it. But at least I have successfully done what you want. I'm converting one of the base to be the same as the other. Okay. Now, in case you have doubt, there is no need for you to memorize or do anything. This is the easiest basic to teach, partly because it is always confirmable with calculator. You can even just randomly try things and you can still arrive at the same answer because you can always confirm with calculator. Do you understand what I'm saying?
Yeah.
So you in exam, you forget everything about this third basic as long as you remember the first and second one, right? The first and second summary I told you. You can just try, and then check with your calculator. So please check with your calculator, am I correct or not?
Yeah, it's correct.
All right. Now with that, you have confidence. Now, why the heck are we doing this? Because I claim to you in my second summary, if the base is the same, usually you can at least do something lah. Okay, you follow that. Now, do you see what kind of thing you can do right now? I understand your conclusion, Keiko, but are you happy with your conclusion?
I guess, yeah.
Hey, same thing all over, right? Just the exact same thing. As promised.
Okay.
You can try something more, more of a variety. Usually I will ask you to just wait in this case 9:30 before continuing, but looks like it's not very crowded yet. Oh, see, your question already. Can I see you at 9:30 instead?
Okay.
Okay. At this point, you are ready to try the slightly more, complicated question, which there isn't much, but there will be, right? If you want. Okay. Go ahead.
Okay.
Yes, Kyoko, I can see you. Yeah. Elliot, you see what you can do by making the base the same. Elliot?
Yes.
What can you do? Tell me.
You can add them together.
I'm gonna use logic here and see whether you can accept that. Since the base is the same, right? If the left-hand side is equal to the right-hand side and the base is the same, then the power must be the same also lah. Logic lah. Okay?
Yeah.
This, you're allowed to write this directly. The moment you write this, you're allowed to write this and things will be easy lah. You don't have to take your own word for it. You don't have to take my word for it. Can we just confirm using the original question? Can you do that, please? Okay. Yoko, yes, I can see you. Yeah. Can you hear me?
Yeah.
All right. So, Kyoko, you sound fresher today. Are you okay? Are you better today?
Yeah.
Very good. What shall we study today? This is the last tuition before exam. We already agreed that this exam will be just a practice, correct? So lessening your pressure, it is important to lessen your pressure. At the same time, prepare well. Right? So you shouldn't expect too much from the exam because it's just a practice anyway, but you should still prepare as well as you can, without the falling sick. What should we do today?
I still have some maxima and minima questions I haven't done.
I don't mind, but you should also practice your crop, your increasing, decreasing, and your tangent norm. Okay.
Yeah.
Yeah, because maxima, minima is only one type. So let's use you already made the Jamboard yesterday. Let's just use that. So Elliot, how is it? Because I don't see any writing. Is it correct?
Yeah.
Okay. Is there anything new in what I explained just now? Is it helping you?
Yes, helping.
Right. So there are 3 summaries, okay? The first summary is the upgrade or downgrade, correct?
Yeah.
The second summary is, should I make the base the same or the power the same or both? That's a summary lah. It depends on the situation, correct?
Yes.
The third summary is whether I am agile enough to change these the way I want them lah. That means the first and second summary tells you what you want, kind of. And the third summary, which is the basic skill usually in class, is to execute them lah, to do them well. Good news is, the third summary is always confirmable calculator. So even if you make a mistake, if you feel that you make a mistake, just confirm using calculator, you'll be happy, right?
Yeah.
Right. So choose the next question, please, Elliot. We will use those three summaries to settle problems that you have.
Can just do
Kyoko, you can just do what, sorry?
C.
At this point, any question you want can do already. Really. Just have to get used to it lah.
Okay.
So give it a try. But do show me the question.
How about 7?
7. Okay. So 7A, right? So let me ask you. What do you think you want to do in 7A? Make the base the same? Make the power the same? Make both the same? What do you think?
Make the base the same.
Which base are we talking about?
10.
To make it the same with who?
With the left side.
The left side have 2 bases and 2 power. Do you realize that? It's not even 1.
Yeah.
If you want to make the right-hand side equal to the left-hand side, I guess the left-hand side better be only 1. I guess that makes things easier lah. Does that make sense?
Yes.
Would you like to then focus on the left-hand side first, in case you can combine them lah? I'm not sure whether you can, but maybe you can lah. Maybe you can. Does that make some sense? That's the way we probably want to approach this question.
Okay.
Okay, so for the left guy lah, only 4 to the power of x and 5 to the power of 2x, right? Only that. Their relationship is times, by the way, which is a sweet thing. Times relationship is usually at least easier. Do you want to make their base to be the same or their power to be the same?
Power.
Power. And you have a decision to make. Into what kind of power? Power x, power 2x, or something different?
Power X.
All right. If that's your decision based on, feeling, right? Experience, then the 4 to the power of x, no need to change, correct?
Yeah.
You only need to change 5 to the power of 2x into, well, something to the power of x. So the question is, what is the something here? That's your goal. Am I correct?
Yeah.
Please do that on paper, please. Okay, Kyoko, I'm following your question. So you put up two question, 3 question, 2 question, 3 question. Right. Tell me when you are starting to do a question, yeah? So
I'm done.
Okay. So I propose that you make the 5 square in 25. It might be easier that way. I propose. And that's also like finalizing the fact that it's going to be just power x, because there's still a power 2 that a bit nagging here and there, right? So just make it 25 now. But you may actually like it more. You may, right? Right. Now, do you regret your decision to make the power the same? Because you have done that. Do you regret it? Is it useful for you?
Yes.
You regret the decision because it does not seem to be useful. Am I correct?
Yeah.
I beg to differ. I think it is very useful. That's your experience is a bit lacking there. I feel that this is very useful. Now, first thing first, can we actually do something when the power is the same? Is there
Yes.
anything that we can do? Okay, then do it. Do it. Let me see your basic skills. I agree with what you did, right? So at least 10 100 to the power of x is simpler than the original. At least there is some benefit there. Correct or not?
Yeah.
But the most important thing is whether this solves the question. So now please equate this to 10. The question is whether this equals to 10 is solvable or not. That's where we know whether our first decision, making the power the same, is going to be useful. Experience speaks a lot here, because if you think that this is useless, you may go back and try something else. If you think that this is useful, you will press forward look. Experience does speak a lot here. It does. Now, what does your experience say right now? Is this going to be solvable or not? Okay,
No.
Kyoko, just a minute. So Kyoko, for part A, I want to emphasize that part A is EMATH, right? As always, correct, Kyoko?
Yeah.
Okay. Now, part B doesn't seem to be AMAT, it seems to be EMAT also. It also does seem to be that. So A is EMAT, B is EMAT. So just to confirm that you want to practice the EMAT part. It's not
Yeah.
very easy also. So that's what you want, correct?
Yeah.
That's fine. As long as you activate your EMAT, please just give it a try. Right, so Elliot, useful or not? Because you're waiting for me. If you think it's useful, you should probably try something already.
Okay.
Right? Don't wait for me too much intuition. Like if you think that you can try something, try that. Right? Remember though, in order to be able to do something, usually either the base or the power must be the same. Remember that. Remember my summary. Right now, the left-hand side and the right-hand side, both the power and the base is not the same. That's why you are slightly stuck. Try to make either the base or the power be the same, if it is possible. If you are having a doubt, write something and test using a calculator. Are you having doubt right now? If you're having doubt in exam, just test. Like just get used to it. Just test lah. You'll be happy. Are you happy?
I mean, the base is the same now.
No. As in, is 100 to the power of x equals to 10 to the power of 2x? I mean, are you having doubt there? Because you look like you're taking your time.
A bit.
So have you tested using calculator to get rid of the, the doubt? You can test, Do you know how to?
No.
You're saying that 100 to the power of x is equal to 10 to the power of 2x. That's what you're saying right now, correct? Hopefully that's true, right? Correct or not?
Yes.
How to test that is very simple. Just put any random x. Just don't use 1, okay? Don't use 1. Put x equal to pi. Put x equal to pi. See whether they're the same or not. Just don't put 1. So are you happy, everyone? Are you happy, Elliot? Are they correct? Is that correct?
No.
You mean 10 to 100 to the power of pi is not equal to 10 to the power of 2 pi? It's not.
Say again.
You are testing whether 100 to the power of x is equal to 10 to the power of 2x. Am I correct?
Wait.
Is that what you're... Have you tested that? I mean, do you want to test that? If you want to test that, right? Just take a very short time. Yoko, are you stuck? Yoko, are you stuck?
Thinking, but I think I'm stuck. Yeah.
Find C first, then we'll talk about B. It's still E-math, you see. I prefer that you practice your A-math first quickly, then go to B. Okay? Okay, we'll go back to B, don't worry. So Elliot, are you happy with your working so far or not? Is your calculator saying that you're correct or not?
Yes.
Good. So you feel better, right? Correct or not? No nagging doubt. Now back to your big decisions. Your first big decision is to make the power the same. Your second big decision is to make the base the same. That is what is happening, correct?
Yeah.
According to calculator, you are at least doing a good job in doing them. You are not making any mistakes. So that's one good thing. Now, are you regretting your two big decisions, or are you tasting the sweet fruits of victory here?
I'm not regretting it.
Okay, then what can you do then? That means you can do something, right? Go ahead, do it. If the base is the same, usually we can do something. Yeah. Okay, looks good to me. Looks good to me. By the way, let me clarify to you, I don't think there is a shorter way of doing it. I think this is the second shortest way. There is a slightly shorter way, which I will show you in case your teacher uses it. Only one slightly shorter way. Shall I show it to you?
Yeah.
I'm trying to say that your working is good, okay? Your working is good and correct. I think this is good, right? Whatever you're thinking correctly. So look at the thing. So your teacher might be might do a door instead log the stand, no? Your teacher might do this. It's valid, right? Okay, and then you will need logarithm. Now, the issue is that this thing needs logarithm, which I feel that I'm very uncomfortable using it right now to you. Okay, but I don't know how your teacher teach. If your teacher just whack logarithm, then at least know that you can do this. So if you're very confused about this, then that's because of logarithm. Yeah, same answer. Okay. So if your decision is right now, I don't care about logarithm, I think that's the right thing to do. I think just care about this. This is only a slightly shorter method sum, and the answer is the same anyway. Okay. Ignore logarithm for now, Elliot. Can ignore it. No. Just continue with your basic skills in this. Come, let's do B. Let me see your big decisions. Let me see how you do it. Okay, Kyoko. Okay, good. I mean, I guess I'm okay with what you're doing. Right, good. Okay, very fast, Amor. So at least you're familiar and comfortable here. Good. Elliot, your first big decision. Make the base the same, make the power the same, make both the same, or what?
I think make base
The same. Where? Left hand side or right hand side or both? Which one?
left hand side.
Okay, I guess I can see why. So please, what kind of base? What kind of base?
8.
Huh? You want to make the left hand side base into 8? Really? Yeah. Really?
Wait, what do you mean?
Because just now I asked you, you want to make the base the same. Well, I think it's a good idea, but where? You say left hand side, correct?
Yeah.
You mean you're trying to say that you want to make the 4, the base 4 into 8, and the base 2 into 8. That's what you're trying.
No.
Okay, so what do you want to make the base 4 or the base 2 into?
Make the base 2 into 4 first. Then it become 4.
Okay, let me give you advice here. Right, so this is practical. You can make 2 to 4, or you can make 4 into 2. Right, you have 2 options. You have 3 options. Sorry, you can make both into something else. Also can, but you choose to make 2 to 4. It is 99% of the time. It is much easier if you choose the smaller base. 99% of the time. That means instead of making 2 into 4, which is a bigger base, it's easier to make 4 into 2, a bigger base. It's just easier to deal with. It's not that you cannot do what you say, but it's just easier that way. Do you understand what I'm saying?
Yeah.
You can try make 4 to 2, and then later on, if you want to, you can try make 2 to 4, and you compare the difficulty. You understand?
Yeah.
Right? These are all practical skills that you need. So please, for now, try to make 4 into 2 first. Okay, understand, Kyoko? So you're missing something. You have to justify that is maximum. Understand?
Oh, okay.
And keep the exact answer also. Oh my goodness. Keep the exact answer also. Oh, you are. Don't make it into a decimal. Keep it exact.
Okay.
I mean, the flow is great. The flow is great, but keep it exact. Okay. Show me how to justify also, and you will go back. Okay, good. Okay, right. Never mind the right hand side. Yeah, just leave it there. Yeah, correct. Let's type one. Now, is there anything you can do on the left hand side? Is there a benefit in doing all this? Nice, nice. Okay, all right, good. Do you like that benefit?
Yes.
Okay, so you don't regret your first big decision, which is to make the base the same. In this case, 4 into 2. You can simplify stuff if you want, but you are in the face of the second big decision. So what should you do now if you don't regret it? What do you think, Alex? What's your next big decision? Oh, Kyoko, you decided to make it double differentiation. I mean, it's easy though, so I kind of support your decision here. Your decision is not bad, I feel. The second differentiation is easy to do lah. Yeah, that's it. Look, right? Nothing else, right? That's the second differentiation. So what's your conclusion? Elliot, how come you're stuck here? Second summary, right? Second summary. In order to be able to do something, usually either the power must be the same or the base must be the same, or sometimes both must be the same. In your situation right now, are the bases the same?
No.
Are the power the same?
No.
So no wonder you cannot do anything. What? No wonder you must make a big decision here. Maybe I should try making the base the same or making the power the same. Because there is no wonder that we cannot do anything here. You understand me?
Yeah.
Right. So what's your big decision number 2? Hey, Kyoko, you're comfortable with part C, obviously, correct? Now, part B, Part B is BMAT, okay? So I try not to explain too much. You have to give it a try, right? So what you want is this one, right? If you have a particular question already, just ask. If not, then I'll start giving you the hints.
Is VW equal to ZY?
Is a VW equal to ZY? Now, to answer that question, you must read what they tell you. For example, they tell you this is equilateral. Is that useful or not? Is that relevant or not?
Maybe.
They also tell you that the smaller triangles are also equilateral, correct? They also tell you that. So to answer your own question, is it the same?
I don't know.
Again, your question is what? Your question is what? Is which one?
Is it
VW equals to
ZY?
Okay, ZY is X, right? I mean, they tell you, I suppose, right? It's X.
Yeah.
So it's VWX. Don't say that they look the same. That's not going to fly. Is VWX or not X?
I don't know.
Then maybe you should assume that they are not the same. Rather than, are they the same or are they not the same? You don't know, right? I mean, you're correct. You don't know. I also don't know. So we better assume that they are not the same. Make sense?
Yeah.
And progress from there. Now, can you progress if you assume like that? I mean, there's this Y, right, to use. I don't know. Maybe you should use, I don't know, right? There's also this 18 centimeter that you have not been using. Correct. Can you progress or not? If not, I'll give you more hints.
No.
Okay. So let's use the 18, okay? Okay, and then the VW. Now the VW is going to be what? Noting the Y and the X. He even specifically defined Y and X, correct? So I think it's a good sign that we must use it. So Kyoko, in page 4, please. In page 4, sorry, page 4. Yeah. What is VW based on, Y and X?
Y minus 2x.
Okay, I agree. So everything is Y minus X. So at least I write that down, not because I know it's useful, but because the question defines them Y and X, so I better use them. That's my only motivation. Understand? I'm not saying that I know it's useful, so I just, and secondly, he purposely tell me 18 lah, so I better use 18 no? That's just how I think lah. So how can I use 18 in terms of, X and Y or something like?
18 equals 3 bracket y 2x plus 3x.
Minus, y minus 2x.
Yeah, okay.
Hello. Yeah, correct. Y minus 2x, right? X plus 3x, lah, correct?
Yeah.
Okay, which I can simplify to 3y minus 3x, correct? Which is equals to 18, right? I can simplify to 6 equals to y minus x. I mean, that looks nice. Maybe I can use it. Elliot, your big decision. Come on. It is not surprising that the base is not the same, the power is not the same. You cannot do anything. It's not surprising. But you're not making any big decision here. You're supposed to try to make either the base the same or the power the same at the very least. Now, why are you stuck here? You're not moving on that direction. What is your decision right now? Make what?
I was trying to make the base the same.
Okay, who do?
I'm making 2 to 8.
No. I told you before. Rather than make 2 to 8, better make 8 to 2. Practically speaking, it's easier. You'll see later why. You'll see later why after you solve it. Do you understand?
Yes.
It's the same advice I give you. Don't do 2 to 4, do 4 to 2 first. Unless absolutely necessary, don't upgrade the base. It's difficult to do. Okay?
Yeah.
Kyoko, we are using the y and you're using the 18, correct? So at least, I'm using what the question gives me. I haven't arrived at the answer, but I should feel slightly good for it. Do you understand? You notice that when you're stuck, you don't even do this simple thing, man. If you feel that you cannot you cannot see what you're supposed to do, you don't do what you can do. I feel that that's a little bit of your weakness. Isn't it obvious that I should try to use the y? And isn't it obvious that I should try to use the 18? Not necessarily leading to the answer, but at least I should try to use them. Don't you think, Kyoko? Right? So keep this with you. Keep this with you first. Now, the area, right? The area. Now, never mind the final answer. Sometimes I feel that this also disturbs you and makes you cannot think. I feel that you look at the answer key and then you will think something so big. Now, just tell me, just use simple logic. How do I find the white area? What's the simplest way of finding the white area?
Minus the small triangles.
Big triangle minus small triangle, correct?
Yeah.
Which is like, that's the obvious EMAT thing to do. Right? There's nothing, mysterious about it, correct? Now, you don't even try that. Would you please try that, please? If it is obvious to you, then at least try lah. Even though you cannot see it leading to the answer, you should at least try. So, Elliot, do you regret the decision? How did you change 2 to, we have a problem. Okay. So, Elliot, 8 to the power of 2 minus x, right? Changing it to base 2, correct? So do it slowly with me. What is 8? 8 is 2 to the power what? Elliot?
Yeah.
8 is 2 to the power what? Kyoko is area, okay, it's not perimeter, please. It's area, not perimeter. EMAT. What do you mean by 3y? 3y is perimeter what? Elliot, 8 is 2 to the power of?
3.
Yes, and you didn't do that thing that you know how to do. Brain, remember your basics. Okay. You're jumping steps here. If you do it correctly, that's fine. Will you do it correctly? Uh-oh, you're jumping steps. Elliot, don't like you jumping steps, especially when you're not certain. What's going on here? I know you can do this. How come you're making mistakes here? Elliot, correct or not? You know how to do this. You at least learned this already, correct?
Yes.
Be careful, yeah. Making a mistake at this part, then obviously it will lead you to errors, right? Obviously, no. Now, big question. Your big decision is the left-hand side, make the base the same. You say that you did not regret that. The second big decision is make the right-hand side base the same with the left-hand side. That's your second big decision and your first big decision. Do you regret any of them?
No.
All right, then continue. Okay, Kyoko, I understand, right? Right, so, I mean, generally, I agree with your e-math. It looks great, right? Looks great. Right, looks great. If this is e-math, this is, I think, going in the right direction. But now the answer key, the answer key say that, look at the answer key. Do you see any Y?
No.
So, is Y a problem?
Yes.
Only a problem if you cannot change it to X.
Yeah.
Which, can you change it to X? In terms of X? Can you?
Yeah.
If you can, then it's not a problem. Please try. Elliot, please confirm your answer, meaning, use calculator to confirm. This point, storing the 5/4 into X will be a very useful thing.
Yes, correct.
Hey, Elliot. Your execution, yeah? Be careful, yeah? Changing the 8 into 2, right? Are you sure you know how to do it? Or are you a bit shaky there?
Now I think I can do it better.
So that's the small things, the details, which you practice in school. The big decision, make this the same, make that the same, yada, yada. Are you more comfortable with that?
Yeah.
I hope you see that they have to work together. You have to make the big decisions and you have to make the small details also. Admittedly, in this is never an easy topic, admittedly. It's confusing somewhat. There's a lot of decision to be made. You have to use feeling and you have to carry out the small details. And it is confusing sometimes. But that means that if you can solve it, then it gives you a sense of accomplishment. Are you ready to do C? Or are you very tired?
Yeah, I'm ready.
Good. Remember my summary to you, yeah? The upgrade, downgrade. Should I make the base the same, power the same, or both? Right. Looking good so far, Kyoko. Hopefully you can simplify the one inside. Take your time, yeah? Slowly take your time and simplify the guy inside. Slowly. Just take it slow. I must admit that the EMAT is not very easy, right? So it take it. What will you do, Elliot? Right? Curious. Okay, making use of the zero. I guess I like it. You make a big decision there, right? Making the base the same. I hope you like the effect. Right? Before looking good, yeah. You can take it slow, but if you feel good, then just whack it. So you notice that it is not the same as the answer key, and I do notice that you make a mistake, so please find your own mistake, okay? You're very close, yeah? But you have to find your own mistake. Yeah, don't think you regret your decision. So what do you do now?
Can I do that? Is that something I can do?
No, you can, but I'm hoping that you will confirm your answer. Both answers, both answers. You're working solid, so if you confirm it and it's correct, then right. Okay, good. Good. Good, you're good.
Only 1 equals to 0.
Can you hear me? Elliot, can you hear me? Elliot, can you hear me?
Yeah.
All right. So you mean the 4 is correct, the -2 is not?
Yeah.
I will confirm again later because I believe both is correct. So I'll confirm again later. You just do part first, you think? Okay.
Oh yeah. I think I didn't write minus in the 2. I think I only need to do.
Oh. I think that matters a lot. So give it a try. Give it a try because I think both is correct. And knowing that is important in exam also. Okay, good, Kyoko. Are you happy, Kyoko?
Yeah, it's both correct.
Yeah, very good, Elliot. Move on. You're gaining something good, I hope. Kyoko, happy?
Yeah, I guess.
Right. Kyoko, you notice that the EMAT part is always different from question to question, right? But the maximum minimum part is the same with every question.
Yeah.
The maximum minimum is standard, and that's why you're very fast. right? I mean, you did make some mistake also lah, so just be careful with that. But the EMAT part, I will call it the creative part because it's different every time. In your exam later, it will be different also, and the maximum minimum will be the same, right? Different and same, correct? Your expectation better be set properly. If the question is the different type, the creative type, the EMAT one, creative type, you shouldn't demand yourself to be able to see how to do it. Do you understand what I'm saying?
Yeah.
It's a new question every time. You don't have the capability to see how to do it until the end. Cannot one. It's supposed to be a creative question anyway. It's not supposed to be standard. You should demand yourself something slightly different. You should demand yourself, I'll do what I can. Not I see, then I do. Wrong demand of yourself.
Okay.
Understand what I'm saying?
Yeah.
Okay. So if it's a creative question, slow down and do what you can. Then it will lead you to hopefully the answer lah. But if it's a standard question, just whack lah. You can demand yourself to know. Okay? Different demand, different type of question. You understand me?
Yeah.
Same thing with the crop one, The crop one is a little bit creative. So take it slowly. Which is question 9 lah. But question 9 doesn't look so hard. Okay, now do what you want. Do what you want. And this is the next question.
Okay.
Okay, Ainesh. Yes, I can.
Hello.
Yes, Ainesh, I can hear you. Can you hear me?
Yeah.
All right. Right. So what shall we do?
We can do statistics today.
Okay. All right. Show me the video.
Yeah, and then Sunday
just-
we can do chemistry.
So that you don't forget, Ainesh, this next week I won't be having tuition, correct?
Oh yeah.
I'm having a trip, right? I'm having a trip.
Oh,
Okay.
that. Okay, then forget it. Let's just do science, chemistry instead.
Okay, we'll continue from tomorrow. Yesterday, sorry. Yesterday's one will be the Sunday one.
By next week, do you mean from like Sunday lesson also don't have? Or
Sunday, that means a full week lah. So starting Sunday until Thursday. Then the next Sunday resume again.
okay.
All right. I believe we're doing yesterday's Jamboard, right? Okay, right. So, good, Kyoko, you're doing all the standard thing lah. dy dt, dx dt, dy dx. Good. Oh, Elliot, that's quite quick. Oh, right, nice. How is it, Elliot? Curious.
Wait, do you ask me something?
Oh yeah. I'm just wondering how is it? You're confirming.
Yeah, is correct.
Nice. So this time you do it quite fast, right?
Yeah.
You're getting used to it. I mean, it's not the hardest question, but nothing is easy in this. So are you learning something new or useful? Or are we just repeating stuff here?
I mean, learning more.
Good. Something new or something useful, hopefully. Huh?
Yes.
All right. Right. You have 8 more minutes. Shall we continue?
Okay.
Right. So far, so good, yeah, Kyoko. So far, so good. So far, you're doing all the correct things, right? Which question, Elliot?
Um, 9.
Be careful of 8, yeah? Unless you're good, yeah? Be careful of 8. Oh, but 9 also, right? Remember the summary, upgrade, downgrade. Should the base be the same or power or both? And complex, right?
Yeah.
Okay, let's see. Okay, oh, wrong. Elliot, do notice that in question 9, the bottom level, at this point, if I say bottom level, you should understand what I'm saying, right?
Yes.
The bottom level. Notice that the bottom level from A to E are either plus or minus, correct?
Yeah.
Which is something that you have not faced before this, like the bottom level having plus and minus. Okay?
Yeah.
Now, bottom level plus and minus, from experience, the immediate thing to do is to make power and base the same. Because bottom level plus minus is a very strong indication that you have to use lab. It's a very, very strong indicator. Let something be something, right? Okay.
Yeah.
And for lab to work, the base better be the same and the power also better be the same. Do you understand what I'm saying? If you don't understand, I'll show you one example. If you understand, we try it.
Okay.
Okay, Kyoko, if you can check the answer key, that would be nice. I mean, you're doing all the good stuff. Ines, do we have a video, right? Come on. We're already 10 minutes in, right? In this case, Kyoko, I guess we can do with decimal line. Yes, yes, that'll do. We check the answer key, Kyoko. Not very complicated. I think we did well. So Elliot, I mean, I'm giving you a hint, right? So base better be the same and power better be the same. The 16 power x. Oh, you're thinking about this. Oh. I'm so sorry. Let me explain the next. Okay, so Elliot, you are trying to make the base 2 here and here to be base 2, right? That's what you're trying to do. Correct or not?
Yeah.
Usually this works, and usually you should do this. So I give you that. But in the situation where the bottom level is plus or minus, this is very strangely speaking not the best thing to do. It's very strange one. The thinking becomes different. Now, instead, you have a feel of this. Instead, I'm going to focus on this and this, and I'm going to totally ignore this guy, and this guy. It's a very weird thing. I'm just going to focus on 16 power x and 4 power x. This is not what I normally do, not what you normally do. You understand, Elliot? It's not normal. Okay?
Yeah.
So I'm going to ignore 2. I'll just leave it there. And then I'm going to make 16x to the power 4x squared. Close to 5, 4x minus 2. Which I'm single-mindedly trying to make 4, and x. That's what I'm trying to do. Can you follow?
Yeah.
Now, why would I want to do that? Something weird. Because of why? Let. Now tell me, let what into what? Okay, Ainesh, I can see that. So moving on to the yesterday's question.
Yeah, the thing is, I copied down all the answers, but I didn't know what was going on.
This is battery, right? Yeah. So yeah, totally know what we want. So are you discussing question one now? Zoom in, please.
Okay.
Okay. Elliot, let what into what if you know if you know the appropriate step.
Let 4x equals to y.
All right. Now you give it a try. I'm pretty sure you won't regret this. And then try to do the same for B and C. This is it's a very different approach.
Okay.
Okay, Kyoko, you don't have answer key. Sorry, this is from your school, Kyoko, correct?
Yeah.
Cool. Oh, then just wait for your teacher, no? What else to do, right? I mean, it looks great, lah. Continue, please. Okay. So, good, Ainesh. Okay. Okay, Ainesh, I'm putting this in page 6, lah. Are you with me in page 6? Ainesh, are you with me in page 6?
Yeah.
Is this electrolysis or battery?
Battery.
Okay, how do you know?
Because there is no battery.
Fair enough. Now, do you have your battery notes? Back then we started already.
Mm,
Go and read them, please.
okay.
Interesting question, looks harmless, but it's harmless. Yoko, stick with me. You want this, right? For maximum, right? Correct?
It's not loading. Wait.
Yoko, correct? Are you seeing something?
Not loading yet. Wait.
Okay. So, Ainesh, do you have the battery note?
I'm looking for it.
Okay. Is it loading, Yoko?
Yep.
Right. So your instinct is to go dVdr equals to 0, right? And I think that's the right instinct, right? Notice that you don't have the V, right? The question don't give you, right? So, but like it or not, you need the VR, you need it. And therefore, that's the challenge of the question. The question is a roundabout way of giving you the VR. Use what they give you so that you will have the VR that you can NVIDIA. So you are the creative part of the question. You understand your situation. And use what they give you to get the VR. Elliot, again, this is a different way of thinking, correct?
Yeah.
So you have to be able to do both, but more importantly, you have to know when to do it. So in this case, I already tell you oh, bottom level plus minus, better do this one. The previous question don't have that situation, so you do the other kind of thing. They are different and you need both. Right? So hopefully you can do part B. Why is your part B different from my B? What's going on here? How come your B is a repeat? That's just let me, you did that just now. We're talking about. That's not line B. Hello. Yeah. Ainesh, how is it? Oh, it's already 15 minutes.
No, I already found it. I'm reading it now.
All right. Please do. So Kyoko, you're doing what you can. Good. Good. Don't know where this leads, but this is good. Right? I mean, there's one more thing that you haven't done, like the volume, right? Volume of cylinder. You haven't done that. Please do that. Kyoko, it's also good. Now, do you see what you're supposed to do?
Find the radius.
Find the radius. What do you mean by that? Sorry.
R.
Find the R. Why do you find the R? From these two things, you want to find the R, really? Elliot, base and power the same, eh? Just like question 8, base and power the same. Ganesh, are you okay so far?
Yeah.
Okay. Elliot, apologies. I was we'll continue talking on one step later. Right? You try to do it yourself, right? Okay. I'll have to attend to other students. Okay. Okay, Elliot. I'll see you next time.
Okay.
All right. Bye-bye. Good job.
Thank you.
So Keiko, I can see you, yeah? Okay. So Kyoko, you want phi as a function of r, right? You want VR so that you can give VDR, correct or not? At least that's what you want, right? Now look at the volume of cylinder. Is this VR or not?
Yeah.
Who's the problem?
H.
H. If H is the problem, you can solve your problem by changing H to R. Correct or not? If you can do that, then H is not a problem. If you can, correct? And you do that using what they give you. Can or cannot? If you can, then at least try that. Okay. Okay, don't forget to go to the gym. What do you think, Anish? I mean, this is slightly new, so Now, what are you saying? You're saying that first of all, GZ is more reactive than X. Okay.
Yeah.
I'll follow you. I'll follow you.
There you go. Oh.
So now you know something. You feel that you understand something?
Yes.
Would you like to write down in your note? Would you like to write something down in your notes? That would be nice. If you feel that you understand something new.
I got it from
switch to your video. Are you using your video? Are you using your handphone?
yeah.
Mic. All right. So you're saying, sorry?
I use the battery notes. There's a sentence that says that of the two metals, the more reactive one will react. So I just use
correct. And that means your note were enough for this one to make you understand. You sure?
Yes.
All right, then let's try the second one. Let's try question. Congratulations, very good. Keiko, what are we doing now?
Actually, we haven't gone through p-value also. Not really sure what that is.
Show me the exact thing, and then I will hopefully give you the good news. Kyoko, are you stuck or are you happy with where you are?
B.
Yeah, I'm also happy. Good, continue.
Okay.
Right. So, Ainesh, this question doesn't look particularly complicated. What's your confusion? I think at this point your note is enough. Like your understanding should be enough for this question. Tell me where you're confused. Yeah.
Zinc is above copper. Zinc is more reactive.
Definitely. So zinc will react, no? Correct. Zinc will react and copper will not, right? Not sure what the porous pot is doing there, but it's very clear that the zinc will react. And that already tells you the electron flow, you know, I feel. So I feel that you ought to be able to tell what goes into the solution and the electron flow. That only like that already enough.
It's correct, right? The electron flow.
Wrong, yeah, no, that's just wrong. It's just wrong. So Kyoko, I'm so sorry I missed this one out. This is volume, okay, not DVDR. Come on, man. Correct or not? That's volume, not DVDR. You still have to DVDR, correct?
What?
So back then, Ainesh, we were discussing the exact thing. So remember, zinc reacts, right? So tell me, therefore, the zinc reaction is what? Zinc becomes what? You tell me first, lah.
Zn2 plus.
And come on. Come on.
Write the formula down.
Yes, please. The formula is important. Kyoko, where's the rule? Hey, pinch you. What rule should we use here?
Product.
Yeah, you're not a stranger to differentiation. Come on, you're not a stranger. You should know that you need rules. Right. So the p-value approach. So Keiko, I'll give you the good news lah. This is just the this is just like this, okay? It's just like this. Okay, this is the sample. This is the Z world. Remember that just now we have the limit here. Remember the limit, right? So let's say the limit comes from, I don't know, 3%. Let's say that, right? Then the p-value, the p approach simply says that here's the, let's say this is a mu original. Then this is how many percentage, right? You can do that also, right?
Yes.
If you have the, then you just compare this percentage with 3%. That's all, really. It is just trying a slightly different approach. Just now we're comparing the limit. Now we're comparing the area.
Also, p-value is
Really,
just the percentage.
the area. Yes.
Area.
It's really nothing. It's really nothing. It's just like that. There is
Then
nothing
why they go
new
define like
here.
this? Okay.
I have absolutely no idea why they make it into something very, but it is true that they present it as something very complicated. It feels like that to me, but it's really just like that one. Just try the question. See whether I'm all correct. So Ainesh, yes. So the sorry. Okay. Hey, I still don't see the react. All right. So I will write down this way, okay? Because they don't want the minus, so I just move it to left, right? Okay, that be okay? This is the same thing as what you wrote, right? Okay, in the Jamboard. Will this be okay or not? If this is not okay, tell me.
Yeah, I can.
Right. So now, back then when we were writing the note, we were discussing this left and right. I was telling you it is obvious to me lah. To you, not obvious, you can protest. You can. To me, it's very obvious that the zinc 2 plus will go into the solution and the electron will go here. Back then, you were protesting, no, it wasn't obvious to you, right? You were saying things like, no, they should go in the same way or they should go in a opposite, I don't know. Right? So I go back to my argument back then. To me, it's very obvious that they will, first of all, go separate ways. Secondly, the direction that they're going, to me, is also very obvious. If it is not obvious to you, it is important to discuss them right now because that's foundational. Because without the foundation, you will be memorizing stuff. Not sure that's the best way for you. So you tell me, Ainesh, does this make sense to you? If you have any shred of doubt, you just tell me. Because this is so important.
Is it because the writer needs to gain electrons so that the electron goes here so it can be gained?
I'm sorry, gaining. Wait. No. You don't need to think like that. There's no need. Although it is true that the other side gains electron, but that's not necessary for determining their direction. Not necessary. Like that one very clear. We can do without that even better is what I'm saying.
Okay.
Let's go first thing first. Do you agree that they should go opposite ways? First thing first. Or should they go the same direction?
They should go opposite ways. But actually, no, I don't know. I think opposite way because you said so.
Right. I'll try to give the reasoning as simple as I can. Positive and negative usually don't travel in the same direction. If positive is going right, negative will be going left. Same thing. If negative is the one going right, then positive should be going left. They don't go in the same direction because they are not attracted. They are not attracted by the same thing. They are attracted by different things, and they repel each other. Even the fact that they are repelling each other is enough to say that they don't go side by side one. That's why they should go opposite ways. Does this make some sense?
Yes.
Then what is left is who goes where lah? Who goes where? Now I'll also try to give the simplest reason so that you understand it. Zinc 2 plus has no problem entering the solution. First thing first, the solution already welcomes zinc 2 plus because it already has zinc 2 plus. It is proof that zinc 2 plus can dissolve into the solution. First thing first. Electron cannot enter the solution. There is nothing to accept the electron in the solution. But zinc 2 plus can be accepted into the solution. That's only one of many reasons. If you can already accept that, that should apply for other questions now. Can you accept that? If cannot, please no.
I can accept that.
All right, then the direction is established. No? Zinc 2 plus enters the solution, electron flows there. The moment you have the flow of electron, everything is almost done. That's why it's very important. Again, are we okay with this?
Yes.
Okay, then you have the half reaction. The rest should be easy. The electron is already established part 1 to be correct. Part 1 is correct. Right? Now the gas bubble, the blue color, whatever, it depends on the other reaction. So you must be able to find out the other reaction. Obviously, this reaction is oxidation, correct? Happening at the anode, correct?
Yeah.
Obviously. So the other reaction will be reduction happening at the cathode. You must be able to write that down. If you can write that down, everything's settled. Please try. Please try to write that down. As for the reduction candidate, it works almost the same as electrolysis. List down the candidate and who will win in accepting the electrons. It is, strangely speaking, very similar to electrolysis. Please do that. Pico, are you okay? Pico, are you okay? So you're muted.
I just realized that in all the working, right, they will just write like calculations, p-value equals the thing already. So they never even explain, it's just normal CDF.
Yeah. Don't know why. Why make it so complicated? I don't know. It's just normal. Precisely, it's just normal. The other one is just inverse normal. It's just like that one. And that's why the normal chapter is important here, right? That makes sense, that now makes sense, right? Other than nothing else. Nothing much, sorry, nothing much. Kyoko, are you stuck? Sorry, Kyoko, are you stuck?
What do I do, Mr. Alan?
Oh, you don't know how to solve it. Wait, let me see for. Oh, you can just press the calculator. In this case, I'll just press the calculator. Really?
The pi
Yeah.
as well?
Yeah. I mean, the calculator can accept one.
Oh, okay.
But I'll be checking for, I mean, this, yeah, if not this one, very difficult to do. It's just that I'm wondering whether there's a mistake or not. So I'll be checking. What's the next reaction? I can, come on. Candidates, please. Candidates for receiving electron at the copper side. Come on, candidates. Let me see the candidates.
Okay.
Just like electrolysis, come on. Candidates for receiving electron. Come on, just like electrolysis.
Gain electron.
Here, at least list down the candidates, right? You are listing down copper 2 plus.
No, just
Copper 2 plus Cu, yeah, copper, sorry, copper, and then SO4 2 minus, okay. Not sure why your candidate is like that, but okay, all right.
That's it. I think so.
I mean, if you're listing down SO4 2 minus, you should at least list down OH minus.
Oh, okay.
Right, it's there. And your candidate is, the candidate list is wrong. Your candidate list is wrong.
The copper rod
And you are still you're still forcing metal to receive electron. At this point, I promised you yesterday, right, I will keep my mouth shut already. I'll keep my mouth shut already at this point. Now, your candidate list is totally off. Your candidate list should be Cu2 plus from the copper 2 sulfate solution. The Cu2 plus from the copper 2 sulfate, the H plus also, copper 2 plus, H plus, no? From the water also. And Cu also, to be fair, yes, Cu also possible. Now you just have to decide from this. Yeah, I'm keeping my mouth shut on you forcing Cu to receive electron. I'm just listing the candidate for you, Cu2 plus, Cu and H plus. Who will receive the electron? Who will, merge with the electron, very likely.
gain electron. It will be H plus. Hydrogen copper. No.
Copper 2 plus or hydrogen?
It will be Cu2
Which
plus.
one? Which one? Which one is, Cu2 plus? I agree with you. And therefore, the reaction is what? No, therefore, what is the reaction? Cu2 plus 2 electron, okay, and you know that part 3 is now correct, look. Right? But part 3 is in all four. Part 3 is all four answers, so that's not a bonus. It just confirms your reaction, which is a good thing, right? That is a good thing, Now, as for part 2, why do you think that part 2 is correct? Why do you think gas bubbles are? What's the reaction?
I put the tick here because the old one I thought OH minus 1, but no.
You understand what I'm saying? Your reaction matters,
So then
your reaction tells you what is correct or not correct,
B.
Now, why is part 4 correct? Let's just explain that.
Because it's the cathode reduction. That's just memorization.
That's fine. Yeah. So good for you. Would you like to add something to your note? Now, Kyoko, are you okay? Are you done with it?
Yeah.
For now, that's it, no? For now, that's it, lah. I mean, until you receive the answer from teacher.
Okay.
Try to do one more question, maybe increasing, decreasing, maybe tangent normal, something, something that hard, something that prepares you. Pico, are you okay so far?
Actually, right,
This-
the way they introduce like the calculation for p-value is through the z-test function on the GC. So like, is there even a need to do that?
No.
No, right?
I mean, no, because I don't even know what GC can do lah fully lah. But no. Oh,
Like I can just use normal CDF, right?
yeah.
Then why they make it so complicated?
I don't. I really don't. I for good or for bad, I find their presentation to be burdensome, for good and for bad lah. Because I have to present this way. You still have to present this way.
Yeah.
That's what they want. I mean, I close my eyes on it. It's burdensome because of that. But I never bother with the understanding from the presentation. Never. I mean, this is going to sound very weird, but you know that as intuition, we are biased. I'm biased to meet people who cannot understand math. Right? I cannot meet intuition. I cannot meet people who understand math. Then why bother with private tuition, right? You understand me, right? So I'm a bit biased in my sample. When I say this, it doesn't mean much, but I've never met somebody who can understand the lecture note presentation in tuition. Yeah, but then again, I'm biased because that's the people that I'm going to meet. There should be people out there who can understand the presentation and do very well. I just never met them. I'm also not that type. So I'm very biased that way. You take it however you want it. You understand?
Okay. Yes.
Because I'm so biased, what I can do is I can provide you with an alternative method, which is what I do. But I cannot, for the love of me, explain why they do things this way. I cannot. I'm very biased that way. Maybe you have more chance to meet people who can understand their approach and derive some benefit from it. You will have better chance of that. You understand me, right?
Yes.
Then if you meet that and they explain to you and you kind of get what they're thinking, even though you may or may not agree, right? You tell me lah. You tell me how they understand it. Right? Okay. You understand what I'm saying?
Yes.
Okay, so Ainesh, you're ready with your note here, right? So look at this battery. Does it look like a battery?
Yeah.
Now, electron flow. Tell me why zinc to copper. You tell me.
Because zinc is more reactive.
So if it's more reactive, then zinc will react. What's the reaction?
This one.
And the flow will be zinc to plus flow where? Electron flow where?
Zinc to plus flow here, electron flow.
Why? According to you. They will never ask one. Just one. According to you.
This one accepts zinc. This one don't accept electron. And also same thingy don't go together.
Okay, all right. So voila. So part 1, part 2, part 3. I mean, everything is done already at this point. So tell me the candidates for the copper plate. Again, just tell me that. List down the candidates for me, please. The candidates for accepting electron, because just now you were wonky there. If you can settle that, then at least we get 80% of battery.
Not a metal.
So list down the candidates for receiving electron for being reduced at the copper side. Yes.
Yeah.
And since you include Cu just now.
Okay.
Now you're very insistent in listing your first candidates. You're very insistent. You realize that this candidate list has no H plus at all, which is what the reaction is supposed to be like. Now, I'm going to ask you to list down the 2 candidates. So in electrolysis, you're forced to list down 2 types of candidates, right? So you usually list down the negative ions and the positive ions separately. So here I'm forcing you to list down the positive ions also, right? Is there any other positive ions? Is there any other positive ions? Right, so you put Cu there, and you should also put Cu on the negative ion list. To be fair, just to be fair. So now this looks a lot like the two candidate list of electrolysis, correct?
Mm.
Now let me ask you something. Which list is more likely to receive electron, as in to accept electron? The negative ion side or the positive ion side?
The what? The positive ion side.
But you list down the negative ion first. There must be a reason for it. You have been doing this twice. I have no doubt that you'll keep doing this until you come to terms with it.
Just the
Why?
that I keep doing all the time.
Yeah, you keep doing this all the time.
You'll just go
That's not a
with-
phrase, right? But why do you list down the negative first? You need to know why for your own sake. I don't know why you say. Why do you do it?
I keep thinking
What
if
attracts you?
I want to-
You keep
But
thinking
if
what? Sorry?
I want to gain electrons. I keep thinking.
Negative ion gains electron. Really?
I mean, obviously
That's
not.
your thinking.
Obviously not.
Mhm.
But whenever like I first list it subconsciously, I think about that.
What is your strategy to, overcome your initial, instinct? Like? I mean, instinct is there, like, what to do, right?
I justified. I mean, I learned it wrongly when I first learned about like positive, negative stuff, and then I guess it just goes away with practice, especially near exams when I practice a lot more. Then the instinct just doesn't come as often.
So you will overcome your instinct with sheer habit, so to speak.
Yeah.
Not sure I agree, but at least I understand your approach. At least I understand what you say. But do be aware of your own instinct, at the very least, can?
Yeah.
So at this point, will Cu be the one accepting electron or H plus?
H plus.
And Cu will not. Because your instinct always say that Cu accept electron. That's your instinct.
Yeah.
All right. If there's no other question for this one.
All right.
Kyoko, okay? Yeah, Kyoko, okay? I mean, it looks good. Everything looks good.
Yeah.
It looks good. Okay, let's move on. Kyoko, okay? Because I'm not seeing anything new.
I'm okay.
Right. Are you trying, example 11, is it, using the p-value, blah, 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 blah.
Example 11.
Yeah. I mean, for your own information only, I find the z-value approach to be slightly more sensible than the p-value approach. I find that using the area doesn't make a lot of sense to me, but some other people do find it makes sense.
I mean, I'm okay with both ways.
If you're okay with both, then you are better than me, in the sense that you can at least accept both. I'm not sure whether A level will specifically define an approach. I don't think so. I don't think they're allowed to do that. But in case the question specifically say using p-value, then you're well covered. Alicia.
I mean, the thing is, if as long as I can visualize it, then I should be fine. So both are okay. Yeah.
Good for you. Ganesh, no more question, really.
No.
I mean, this is the slightly harder question. This is a slightly harder version of battery, fair enough. If you want us to talk about this, you can. Kyoko, anything else to practice?
I have more questions.
Oh, it's 10 o'clock.
Maybe
Yeah,
do
but it's
a-
10 o'clock.
Yeah.
Okay, good. Now, before the exam, if you send me any question using WhatsApp, I'll answer. Okay? I'll still
Okay.
answer. Okay, I'll see you next Sunday. Next Sunday. Sorry. Next Sunday. Right? Good job, Kyoko. Treat the exam as just a big practice. Okay?
Okay. Bye-bye.
All right. See you. Bye. Anesh, sorry. You want to talk about this? If you want to, I expect you to ask questions. I mean, I can explain, but I think it's better.
Is it gonna be tested? Is this tested?
For your syllabus, I'm not there.
Okay. Then I'm gonna go to this last
Maybe
one.
maybe we do questions. Yeah, maybe that.
Yeah, because all of this top
Oh.
part, we covered this yesterday, like especially this part. We covered
The
all.
zinc copper voltaic cell. Yeah, same thing, right?
So just this part. Why does this one I need to just ask you? Why does it leak after some time?
I'm sorry, this is part B, C, and zinc carbon. Sorry, how come we suddenly have zinc carbon battery? So I'm not following.
This one.
There. Then you better understand the zinc carbon, know what to do.
Do we really need to understand this? Because this looks extremely complicated.
It's not. I mean, it just looks extremely. It's not easy. It's difficult. It's easy to understand.
Okay, then I
To be
guess
fair, okay. To be fair, sorry. To be fair, versions of this do come out in locals quite often. So it's not the simple battery. I'll call the copper zinc one the simple battery. The more practical battery, the one in zinc carbon, does happen quite a lot. To be fair lah, in the local syllabus. So yeah, you decide. Look. Anyway, if you're discussing this, we'll probably discuss it on Sunday anyway, right?
yeah.
In detail, right? So you can decide on next Sunday, okay?
Yeah.
All right. For today, anything else?
Nah.
Then I think your battery have improvement. Hopefully you'll carry it, right? I'll see you next Sunday. I mean.
All right. Bye bye.
Bye bye.
Where are you going?
Japan.
Japan. Okay. Bye bye.
Right. Bye bye. Nico, any last question?
No, I'll finish up the hypothesis testing and the sampling thing by the end of next week.
No rush. No rush. I was
Next week
waiting
is very chill
for.
for me actually. Yeah.
I'm sorry, you're saying?
No, next week is very chill for me. I have only 2 days of school.
And then SYF. Really? Is it?
I mean,
Because of SYF, right?
SYF is
SYF
kind of a
is-
holiday for me because I like performing. Yeah. And I have HPL on Wednesday. Monday is a holiday, so yeah, it becomes 2 days
Happy.
of school.
Correct.
Yeah.
Happy is good. I'm just waiting for the the most difficult normal question and the most difficult hypothesis question. We are not there yet. It doesn't really matter. We'll get there soon.
Wait, the normal
Once we are, yes.
like the more difficult normal questions that I've seen in the tutorial, right, is
Yeah.
I just have to redefine the variables, right, and then like use
Correct.
the
2x minus 3y and then redefine the mean.
yeah. I'm
If
able
you
to do
did it
that lah, so
correctly, happy.
yeah, I'm able to do that. Like this is the first tutorial where I don't have any questions for actually. The
Oh.
normal one.
Yes, that's good. I mean, in this case, I feel that's good lah. That is good. That is probably very good. Probably you do understand something lah. Probably. Right?
Yeah, I think so.
The hypothesis one also. So you will see slight variation, slightly more difficult than your P and Z value only. They will push the envelope, they push the boundary.
Okay.
And remember what I said about going from binomial or DRV to normal. That happens. I don't think that you encounter in tutorial, so you have to encounter it elsewhere. But I guess that means that's much later. That's much later in our exam practice.
Okay.
But I'm already pushing the boundary already. This is already like the edge cases already. So what I'm trying to say is that your understanding is probably quite good right now. Probably.
Okay.
Right. Then I'll see you in next Sunday. And enjoy your semi-holiday.
Okay.
Take care. All right. Bye-bye.
Bye.